Okay. Let's see. This is a video for the solution to the event. I worry if the video is too boring, so I put some music. Okay, so if you see this, please check if you can hear the music and also my comment. So let's start. So this is the exam I did last week. So I already answer how to get the first problem. So I'm going to do the second problem today. June 9th. So this is the second problem. So the problem is to minimize 5x1 squared plus x2 squared plus 9x3 squared minus x1 plus 10x2, and the initial gas is 555. Okay, so in the first solution, you need to use Newton's method. So to do that, we need to get a gradient, which is going to be 5x 10 minus 1 and 2x2 plus 10 and 18x2. So that's how the gradient looks like. And what will be the Bayesian? It's gonna be 10 to 18. And what will be the inverse look like? Basically 1 over 10, 1 over 2, 1 over 18. The rest are just 0. Okay, so let's start. x1 equals to x0 minus Bayesian inverse dot product gradient, and using x0 to plug in. So to solve that, we will have 555 minus 1 over 10, 1 over 2, 1 over 18 so plug in into the gradient function. So 50 minus 1, so 29. The other one it will be 30. And then 18 times 5, that would be 90. So just for me, I would like to use the letter. So in your exam you have calculator. I could have calculator as well. So 5. Right? So that would be the first position. Second one. That's your solution. Point 1. And 10. Okay? So, you need to do a conversion check. So check the difference between the current one and the previous one. So what you get, which you need to truly get it. So use calculator again. Everything we have. So we need to learn the length of this. So square root so that would be the length 16.5, which is larger than -2. So we need to continue. Now k equals to k plus 1. So now k is 1 because we start with k equals to 0, right?
지금 내가 하는 얘기 널 아프게 할지 몰라 아마 날 죽도록 미워하게 될 거야 내가 예전 같지 않다던 네 말 모두 틀린 말은 아니야 나도 변해버린 내가 낯설기만 해 너무 착한 넌데 난 그대로인데 I don't know 내가 왜 이러는지 서로 사랑했는데 넌 여기 있는데 I don't know 이제 날 찾고 싶어 Baby I'm sorry 너와 있었던 lonely 사랑하긴 내가 부족한가 봐 이런 못난 날 용서해 I'm sorry 이게 너와 나의 story 사랑이란 내게 과거가 네 곁에 있어도 baby I'm so lonely 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 네가 잘못한 게 아니야 내가 이상한 거야 이미 오래전부터 난 준비했나봐 이별을 정말 잘해주고 싶었는데 하필 사랑 앞에서는 왜 이렇게 한없이 작아지고 외로운지 너무 착한 넌데 난 그대로인데 I don't know 내가 왜 이러는지 그토록 사랑했는데 난 여기 있는데
Let me check if
I
I'm
don't
reading this
know 이제 날 찾고 싶어 Baby I'm sorry 너와 있었던 lonely 사랑하기 내가 부족한가 봐 이런 못난 날 용서해 I'm sorry 이게 너와 나의 story 사랑이란 내게 과분한가 봐 네 곁에 있어도 baby I'm so lonely 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 'cause I'm just another girl 이 밤이 외로워 난 calling 견딜 수 없어 Goodbye 'cause I'm just another girl 너무나 외로워 지금 네 곁에 있어도 baby I'm so lonely 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 baby I'm so lonely 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 baby I'm so lonely 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 baby I'm so lonely 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 lonely
So in your exam, you should calculate everything out. So this is how it should be. And over here, second iteration when I plug in,
그렇게 너무 편하게 굴지 마요 아직 너와 난 남이니까
so of course I get the same result.
어린애처럼 보채지죠 마요 아직 시작도
So
안
that's the answer
했으니까
for this problem, and later on we will check different methods and see how the other methods tell us. So if you use x2 to minus x1, you actually get a zero vector, so the for 0, length is 0, so it's of course smaller than the input of 3.
차갑게 식어버린 내 가슴은 아직도 그리워요 그리워요
So that actually, if you get this, you got 30 points. That's a lot of points. Very easy one. Let's move on to the next one.
어쩜 그렇게 해맑게 웃어요 자세히 보니 슬픈 표정이야 I know I've been there before
So now I'm going to work on the
계산적인 사랑은 싫어 살짝 지쳐 있을 뿐이야 난 괜찮아
based on season, he said that we want to continue this.
나를 떠나보낸 그가 아직 너무 미워요 차갑게 식어버린 내 가슴은 아직도 그를
My music is too loud. How do I handle this? Better? Is it better? Is it better? Okay. Is it clear? Let me. So my music was too loud. Let me check by myself.
So the music was too loud. Let me check by myself. So the music was too loud. Let me check by myself.
Maybe music is not. Oh, my student says it's better. Okay. Okay, so music cannot be too loud. The problem of this streaming is that I'm using my laptop and the fan is very loud. So the video has a lot of noise. Maybe I need to buy a microphone later on. So anyway, let me continue to work on this maybe the most time consuming one. Okay, so CP is decent. What you need to do first is to have your equation. So you need to make sure it's minus and alpha 1 times plugging in. So 49, 20, don't make the same mistake again, and then like, right? 49, 29, yes, correct. So you will get 5. Actually, I don't want me to write those again. So now I need to get what is F alpha. So just plug in. So 5 times 5 alpha squared plus 20 alpha squared plus 9. 5 minus 90 alpha squared minus this guy plus 10 times this guy. So this is a long function of f alpha. So let's I usually actually you don't need to expand this. You can directly get f prime of alpha, but don't forget about the chaining. So 10 times negative 49, and then do this 2 chain rule 18 and then here you have the negative 49 negative 20. So this is your f first f prime, and what will be the f double prime look like? You have 10 negative 49 square, that's it, yes, plus 2 negative 20 square plus 18 negative 90 square. Yes, that's all. So I have an initial gas. Let's say alpha n equals to 0 equals to 0. I can use any initial gas, and then my alpha 1 could be 0 minus the whole thing, just plug in, right? So it's gonna be long. Plug in, so I have 10 negative 49, and then 5 plus 2 negative 20, 5 plus 18 negative 95 plus 49 minus 200. So what's underneath? I have 10 49. Actually, let me calculate out the bottom part. So 10 times 49 square plus 2 times 20 square, and then plus 18 times 90 square. So the bottom part will be 170610. Okay. So how about the top? So let me calculate the top. So negative 10 times 49 times 5, negative 2 times 20 times 5, negative 90 times 18 times 5, plus 49 minus 200, so negative 10 49 5, negative 2 times 5, negative 1895, 49 minus 1. Okay, so the negative of this. So 10901 over 170610. So let me get this number. Over 7270. So this is a number like this. Okay, and to be correct, you need to correct process is actually that you need to do this again. You need to calculate the alpha again. So and of course you need to do convergence check. You need to say alpha 1 minus alpha 0. So what you get is 0.0639. It's larger than 10 to the negative 3. So you need to do it one more time. N equals to n plus 1. So alpha 2 right now becomes alpha 1 minus 170610, and here is the top. Okay, but too many, so let me get the top over here. So the top of that equation is basically plug in the whole thing. Sometimes when I do it in the exam, I don't even, for myself, I just type in everything in my calculator. I don't even write out everything sometimes. When I was doing an exam, I think it's okay for the professor, and for me, if you do that, I'm okay, because it's impossible for you to copy someone from your left because it's too long. It's really depending on how you operate your calculator. If you have something incorrect, it's incorrect. But I'm just writing them out just to show you the process. I'm trying to plug into this f prong of alpha. So actually, if you repeat all these again in your exam sheet, of course it's gonna take a while. Yeah, so it's really depend on you whether you would like to write them down again. But most of the time, the operation is many of the operation is in your calculator. Okay, so now I'm opening my calculator. I'm getting those. trying to be focused so I don't make a mistake. You can listen to the music if you're boring. Okay, so what you get at the top is actually a very small number. Okay, let me double check. 490, 5 minus this, negative 40, 5 minus this, negative of this, should be correct. So get back to my equations. So therefore my alpha 2 equals to what? 0.0639 minus 0.9790 over 0.70610. Of course, it's the same thing because it's such a tiny number. If you are experienced enough, you don't even type it in your calculator. You know, actually, the alpha minimization tell you the right solution at the first time. Okay. But to be correct in your optimization, you still need to do a second iteration. So the convergence check, of course, gives you 0, and it's smaller than 10 to the negative 3. So your alpha star is your alpha 2 and is 0.0639. That will update to this equation, right? So get back to the main procedure. My x1 now will equals to 5 minus this times 49 times 20 times 90. And then I'm relying on my calculator to tell me the answer. my friend is online. Yes, you know, my audience are students, so I need to, listen to something that students like. Okay, the solutions are what? 1.8689 and what? Oh, I didn't show you my I basically did this, calculating the 3 components in here. Okay, so 3.7220 negative 0.7510. Okay, so that would be first attempt of your steepest descent, and of course that's not the solution. You just need to do the whole thing again 2 more times. But of course, before you move on to the next iteration, you need to check if the solution is converged. I need to move on to my next page. Copy this. Paste that here. Do this. Do these. And then do this. Delete. So I had this. And what else? My X initial is 555. So let me take this. Paste that here. So let me do this. Okay. So my difference between x1 and x0 will be some vector. So let me do this. 1.689 minus 5. 3.7220 minus 5. And what? Negative 0.75110 minus 5. Okay, so that would be negative 3.1311, negative 1.2780, negative 5.7510. Oh, okay. Just checking my music. Okay, so I need a calculation of the length of this vector. So square root of yes, 3.1311 square plus 1.278 square plus 5.751 square. So that will be 6.6717 is larger than 10 to the negative 3. So you need to move on to the next iteration. So my iteration number k becomes k plus 1, which is 1, and then I need to do the steepest descent again. And following the steepest descent equation, I should have x2 equals to what? x1. x1 is right here. Minus a new alpha, some value I don't know, and then now you need to plug in to get the gradient of this. So what is my gradient? Let me copy that. So my gradient look like this. I just need to plug in. Okay, so I have a calculator. Make this smaller. Okay, I have my calculator. 10 times 1.8689 minus 1. 2 times 3.722 plus 10. 18 times 0.751. So I should have 17.689, 17.444, and then negative 13.518. Okay, so using this, I can formulate my f alpha again by plugging in x2 into my original function. And what does the original function look like? The original function look like this. Excuse me. Copy it. Paste it here. Right? So just plug in. Plug in. Maybe now a louder music because a lot of a long plugging in. Okay. Very long. Okay, so that's your f alpha. So I'm not trying to expand this. I directly derive what would be my f prompt. So remember the chain rule, don't forget. Okay. So this one I should have the coefficient here. So 10. Okay, so that will be my F prompt. And I need to get my F double prompt. My F double prompt will be square here. So it's 2 square here. Square here. Then you could get this number first. So I'm using my calculator, showing you what I did. Negative 10 times 17,698 plus square. Oops, so there's no negative. Square here. Plus 2 times 17.4444 square. Then plus 18 times 13.518 square plus 17.689 minus 174.44. So that will be what? A large number. 68701. So 6870.1, because that would be 10 to the power of 3, right? So let me turn off this. Double check if I make any mistake. Hold on. I made a mistake. I don't have these right here because after second order derivative I shouldn't have those. So I need to correct some of my previous calculation. So I should have 70268 and my point is right here. Yeah. So I kind of feel like, hey, I think I didn't, something was different. So I go back and see my first iteration. I figure, hey, I realized there's no alpha. There's no alpha in those. So how come if I do a derivative again, how come I have those, right? So usually during the exam, you can always check what you have done before you move forward. Otherwise, you waste your time later on, right? So let's continue. Get alpha. Of course, I would like to start with initial gas of 0 because that's given me the most convenient way of finding alpha. So my alpha 1 equals to alpha 0 minus the bottom part is f double prompt, so that would be this, right? So how about the top? The top is the alpha 0, plugging in your f prompt of alpha. So plug in. The plugin, I should have 10. I think after this exam, this will be the last time you would like to use this method because it's taking such a long time to calculate. Yes, that's why people introduce more advanced methods like conjugate gradient. Okay, so we just need to get this whole thing. Okay. So let me continue at the top, and I know I have to start here, so I don't like underneath my camera. So equals what? Calculate. So I'm going to do that. So this is 689 times 10. And usually if you have an engineering calculator, it's faster. If you use like myself, I'm using the laptop. This is taking longer time, but if you have engineering calculator, it's really fast. Typing, but don't make mistakes. I'm still thinking about should I use the same way to do online lecture, because using this way, this is Facebook streaming. I couldn't see you, so I'm not sure if you learn, or I'm not sure how is the live the condition. So what if I missed something, or what if the internet was poor? Then I can only see your response probably 1 minute later, and probably I forget what I said earlier. So we're still trying to find a way to do nice online broadcasting for online lecture. Okay, let me double check. So I will have some negative here, so overall I have positive 799.9302 over 7026.8. So what's that? 799.9302 over 7026.8. So that's 1138. Okay, I'm blocking it. So yep. So that would be my alpha 1. So I think in the past, some students asked me, hey, how come my alpha is always the same when in every iteration? From here you can see previously our alpha was 0.0639, but in the second iteration is something different, 0.1138. Okay, so usually, I mean always, should be always, your alpha only if you're moving to a place that is having, well, in what case you may have the same alpha? I don't think so, because usually your function is very non-linear. So in every iteration, you are basically trying to find how far away your x will be moving forward, and supposedly along that direction, the function is having a very different shape than the previous directions. So supposedly the how much thank you, Professor Leo. So supposedly when you try to move along the current direction, the amount of your movement should be different. That's why your alpha, the step size, should be very different. Okay, so let's continue. Over here I need to do a convergence check. I need to evaluate the difference between alpha 1 and alpha 0. So this difference actually is basically the size, the 0.113a, but it's too large, so you need to do it again. So you need to do alpha 2 again. So alpha 2 will equal to this minus 6.8 and something huge here. So I'm going to say top again here, and I have no space. I need to move on to the next page. So I need this. Okay, and what's the top? The top basically is your half front. Okay, so here. Okay. So you need to plug in, right? Using this. This is your alpha 1. You need to plug in order to get the top of this term. So what would be the value here? I listen to this song a lot because whenever we professor are doing research, writing a paper, I feel so lonely. So this song is always telling me how I feel. It's a sad song, and it's an old song. So this is in your exam sheet. I don't think you need to write down the whole thing here because like I said, it's taking a while. It's taking a long while for you to calculate this. You just need to type those in your engineering calculator and then get the answer. Okay, so that's how the top looks like. Okay, so let me get this, and using my calculator here. Of course, all these can be done by using the computer code. But in the exam, you don't have the computer. Trying to be very careful to avoid any mistake. long calculation.
그렇게 너무 밝히지 좀 마요. 세상은 원래 어두우니까
Almost there.
어쩜 그렇게 해맑게 웃어요.
Okay. Again, very small number. So of course, when you plug back, plugging back to the original equation, you will get the same answer. It's 1138. So it's the same as your first one. That's why you have the converge, and the optimal alpha is your last one. And now you could plug back to this one. Plug in, right? Plug back. Oops. Someone might see some question on this. Everyone is asking money from me. To wire some money to some company so that they can do experiments. Yeah. Okay, let's continue. So over here, I should have minus what? The new alpha.
I'm gonna make this simple for you. You got two choices.
Okay, and then multiply the gradient right there. Okay, then get everything by your calculator. 1.8689 minus 0.1138 times 17.689 and 3.722 minus 0.1138 times 17.444 negative 0.751 plus 0.1138 times 13.518. Okay, so the answer is negative 0.1441, 1.7369, 7873. Okay, we can actually do a comparison to the true solution by Newton. The true solution by Newton is here. Just use it as a reference. You don't need to do it in the exam, but just to check. This is by Newton's method. You can see it's not close. Not yet close. It's still far away. So every time when I do this, I always would like to, just quickly check if I made a mistake during exam, because I know steepest descent is taking a long while to solve. So usually I will do this. I know. This is my 5.5. This is my. You cannot see the Z, but it's fine. Here is 5.5, and if the true solution is actually somewhere here, right? This is close to that. From 1, look, somewhere here. That's actually your true solution by Newton. And if you check your steepest descent, you have this earlier. So earlier you have this. That was your x1, right? You can kind of see where it is. 1 point, so somewhere here, 3.7, somewhere there. And what's the new one here? Like here, and then 1.7 something here, somewhere there. So it's like moving along this direction. And we can do one more iteration to see how it's actually moving. But because this is a 3D problem, we won't be able to see if it's actually making a 90-degree turn. Only if you would like to check, but I don't want to. So let's continue. But before you continue, of course, you need to do the convergence check to claim that this requires another iteration. So you need to calculate the error. So let me negative 0.441 minus 1.689 and then 1.7369 minus 3.722 0.7873 minus this value 7.1. So I have negative 2.013, negative 1.1, and then 1. We'll just check. It's fine. Okay. So yeah. But since I'm checking it, let me show you something. This is the directional difference between the previous one, the x1 and x0. Just want to copy this to here. This is not necessary for the exam, and just to show you. So this guy is the directional difference between x1 and x0. This is the directional difference between x2 and x1. So supposedly the dot product of these two should be 0 because they are perpendicular. So I'm just checking if they are perpendicular. So how do you do dot product? So let me show you. 3.13. 1311 negative 1.278 times vertical. I'm transposing the second one, so this become a dot product between the first vector and the second vector. I hope it's close to 0. It is. It's a very small number, right? Because we do some rounding for every number. That's why it's not exactly 0, but it's very small. So this is meaning, what does this mean? This means previously when we move from x0 to x1, this is the direction vector. Okay, and then when we move from this one to this one, this is the other direction vector. So we did two movements from 0 to 1 and then 1 to 2. So these two vectors are supposed to perpendicular to each other based on the way steepest descent perform. So what I did was I made a dot product between these two guys, and then I figured, oh, actually it's very close to 0. Let me show you again. I did this dot product and I realized it's very close to 0. So which means it's very high possibility that I made this right. Probably no mistake. Okay, so that gave me more confidence about what I did. Okay. So when I was a student, was I this boring that always checking my process? I think I did. So this is just to help yourself to make less mistake. Okay, so you just need to do this one more time, so it satisfies the exams requirement. So let's do it. So what do I need? I need x2. Copy it. Paste it here. Cut it. Delete. Paste it. Okay, so that would be my x2. Now I need to move on to my x3, because previously, I haven't checked if this vector is having is small enough. But actually, if you get it out, let's make it official. Okay, let's truly calculate it. So square root. Let's do the right way. Of course, this is not even close to 0. Okay? So the length of this directional vector between x2 and x1 is way larger than 10 to the negative 3. That's why we need to move on to the next stage, where my iteration number plus 1 again. So now I have k equals to 2. Okay. Here I need to minus a new alpha times the gradient. The gradient looks like what? The gradient looks like this. Like this. Okay, so I need to plug in. Yep, that would be my gradient, and we just need to get those. Okay, get those using my calculator to avoid mistake. 0.1441 times 10 minus 1. Oops, I should use negative here. So I have positive. Okay. You know, my alpha looks like this, my 2 looks like this. So sometimes I I make mistake in exam. So since I know I wrote my 2 like this, so I tend to wrote my alpha wider, so like a fish, so I won't make a mistake during the exam. Yeah, you need to understand how you wrote so that you don't make mistakes, stupid mistakes. 7369 times 2 plus that. Okay, supposedly this is how it look like. Should be right. Okay, continue. I need to plug this in to my original problem in order to get a function of f of alpha. So f of alpha is like plug in everything. Let's drink some water. Okay, another plugging in. So this is how your f alpha look like, and then you need to get your f prime of prime of alpha. So let's do this. Remember the chain rule. I made a mistake. I forgot to multiply by 18 right here. Oh no. So, what's that? 18 times 0.7873. So I should have... Let me use a red pen to show you what was wrong. 14.174. No. So my incorrect term was this one. I feel like how come this is having the same value is quite weird. Okay, continue. Oh, also this guy is wrong. Okay, continue to do the derivative. Is it right? Yep. Then let me do a separation here and continue to do F. double prompt. Okay, let me turn off the calculator. And I think I should start from here so I don't block myself. And let's do the F double prompt. Yep. Yep. That should be it. And let's get this number. Okay, so the number is 40376 and my dot should be here. 4,000 something, right? So that would be my F double prompt. And I should start my subproblem with the initial gas. And my initial gas I could start with again using 0. And my f of 1 equals to 0 minus f prime of f of 1 over 4037.6. So I just need to plug in to get f prime of f1. So f prime of f1 equals to what? Plug in this guy. So get this. Okay, supposedly is this, and then use your calculator to get the whole thing. And you have okay, so your alpha 1 equals to 3AA.3303 over 4037.6. So what's that? 3AA.3303 over 4037.6. So that's 0.0962. Okay, you have this. So that would be your alpha, and of course do a convergence check. It's gonna be this. It's gonna be larger than 10 to a negative 3. So you need to continue n equals to n plus 1 equals to 1. So the next iteration you have this. Right? Here I made a mistake here. This should be 0. Okay. So plug in Let's try it. Another mistake here. So plug in. Using what? Using this. F1. Such a crazy calculation. Actually, it's not crazy, it's just a long. Okay. And use calculator to get it. And moving on to the next page. Calculator. Should be alright. You get a very small number. Again, of course. So if you plot back, of course, you will get a very close number to alpha of 1. What's the alpha of 1? It's 0.0962. So the difference between your 2 and 1 is 0, and it's of course close to smaller than 10 to the power of negative 3. That's why your best alpha is your alpha 2. So which equation you send back? You basically do this. And get this. You get the next solution, and you can finally stop, right? So get this by your calculator. Okay, so what you get in the end is is it close? Is it closer? Let's check those again. That was our discussion earlier. So this is how is this one? I think some mistake. This is called X3. That was called X3. So this is called X3. And this is actually my X2. And based on my new one, my solution should be somewhere here. So it moved down a little bit. So the true solution is like way over there at the bottom. So of course in steepest descent it's taking a long while. Okay, but if you would like to check if you made any mistake, you could. Let me show you. But these are just references. And this is the drawing I made earlier. To check if I made any mistake, I need to do convergence check. So calculator. I'm using 0907 and total is 7 negative. Use this to minus what? It's 2. Negative 29 to 1. So 3 and 7 is 8. So that would be the difference. And previously, the vector from 1 to 2 is here. We could, in the exam you don't, but we could, over here, to check if those two are perpendicular. If so, that means supposedly you are moving to the right direction. So let me show you a dot product of this. Transpose the second one. Yeah, again, you are the dot product of the vector from 2 to 3 and the vector from 1 to 2 is very close to 0. That means these two vectors are almost perpendicular, or it's actually truly perpendicular, but we have round off error. That's why we have some value numerically not exactly 0. But this is just to show you that your current iteration is moving to supposedly a right direction, which is a perpendicular direction. Okay, since what? Initially, where is my initial? Here I start with here I start with k equals to 0, and then when I do a convergence check here, my k become 1, and when I move on to where? When I move on to here, k equals to 2. I said k larger than 3, so since k right now is 2, not yet converge. So we need to do one more. So in the exam, I should have told you that we could stop right now. But since I already asked you to do it, let's do it. Let's do it. Okay. My x3 is here. And this. My x3 is here. So now in the previous slide is not yet converged. I need to continue to do it because this error definitely is still larger than 10 to the negative 3. We need to continue. So now k equals to k plus 1. But we always do this k equals to k plus 1 after the convergence check. So when we check it earlier, the k was 2. It's not yet satisfying my termination criteria. So I need to move on. And when we move on, k could plus 1. And you need to do one more time until you meet the next termination, the convergence check. So now k equals to 3. We know if we do one more time, we could stop. So let's do it. So k4. Minus alpha 3 times the gradient. What does the gradient look like? Gradient look like this. But different numbers.
Hey boy, look, I'm gonna make this simple for you. You got two choices. Yes or yes.
Okay, see. Okay, now plugging back to my Mac. Actually, let me do this. To save some time. Okay. Okay. Since I'm using iPad, I'm allowed to do this. Plug in. Okay. Finally, plug in. Now we need to get at front. Okay. And then I can use these. Okay, and then move this here so you can see it. Okay. To save some time. Okay. Get this guy here. Have double run. Equals to what? Calculator. Okay. So start with alpha 0 equals to 0, alpha 1 equals to 0 minus f prime of alpha 0. So f prime of alpha 0 equals 2. plugging in. Calculate it. Double check. Should be alright. Okay, so your alpha equals to calculator. Ugh. I'm sorry, students. Next time, only do this twice. I would never ask you to do this for 4 times. Too many times. Feels so hot right now. Oh. Continue. What's next? Oh, convergence check. So alpha is 1 minus alpha 0 equals to this. Larger than 10 to the negative 3. So we need to do one more. And equals to alpha 1. So alpha 2 equals to alpha 1 is this guy. So over here, f1 of f1 equals to what? Over here, points, these guys. So this equals to what? I had this earlier. I had this guy. Yep. I'm just lazy. Put over here. And then we need to and over here. You get something was wrong. If you get a number like this, something was wrong. Because usually you get a solution very fast in one iteration. So when you see that you may be making some mistakes, you better go back and check. Check the coefficients. Checking the coefficients. Yeah, this is right. This is right. This guy. Ooh, made a mistake right here. This is how we should go. Still strange when we continue to debug. Plus, here's a plus. So if it's a plus, that means previously when I was coding this, I made a mistake. There was a plus here. This should be a plus. So no. This is actually -1, 1. Damn. So what was that? A very small number. But still not yet converged. Not yet. So, and in here I should be using this long guy. Yep. And then changing these to 5. Then I should be getting some value very small. Yep, very small. So that looks correct. So you will be getting the same number, and the difference between the second one and the first one is 0, so that will converge, and your best alpha is actually this guy, and you plot back. You plot back, you are using this guy. Then you need some calculation. And you have okay, and we could look back to what we had earlier. These are what we had earlier. Copy. Just to take a look. Here's my x3 here. These are just taking a look. So my new solution will be somewhere. Actually, it doesn't move much. It doesn't move much. It's the right solution. I need to. It's moving so slow. Steepest descent is moving so slow. Goodness. Anyway, that's steepest descent. It's moving slow. Yeah. It's like almost move a little. We can check how much it moved by doing this. So the movement is very small. But still, it moved. It moved. And let's see what's the length of this laser. Okay, so it's still larger than 10 to the -3, but in our termination criteria we said since k now equals to 3, so finish. So So you need to specify your X star is actually your X4, and it should be that's the answer of your next problem. Let's do this, and you get 30% if you get up to. I think I will be very nice on these because I know it's taking so long to get those. Now finally, the next problem is the C, using conjugate gradient. And we know using conjugate gradient we don't need to do the first one because we did it in sequence descent. We can directly start from second iteration with my x1 equals to what? Let's see. Here. With these information, and I think I had my gradient calculation earlier. Let's find it. I don't want to plug in again. Just want to use what I had earlier. My gradient is here. Okay. So my gradient up to 0 is here. I need my gradient of 1. Gradient of 1 equals what? And this. Gradient of 1 is what? We already did. So this is what we had earlier. We can already start, and right now our k is already 1. So my x of 2 equals to x of 1 plus a mu alpha times d of 1. So what is d of 1? D of 1 equals to negative gradient of 1 plus the current gradient dot the current gradient over previous gradient dot the previous gradient times the previous d. Previous d basically is my negative gradient, 0. Okay, just need to calculate this. So this will be okay. No. Times the value calculator, and then top product. So the norm of 17.39, 17.444, negative 13.548, the norm, and then square. That's basically your basically this guy. 799.9302. Right? When you do the product with yourself, then you will basically have your norm and then square. Then you land on yourself and then square. Okay. So what's next? The bottom. Bottom one is your 20, 90. Yep. So this will be 10901. Yep, basically this. So what's the value? 9920 9302 over 10901. That would be, let me write it down right here. Okay, so that's what we need for here. And let's get this. And the answers are that will be the new direction, and we need to do line search. Okay, let's do line search. Copy this. Actually, then just stay in the same page. Okay. My 2 looks so much like alpha. Okay, be careful. So now, maybe I move on to the next page because it's not going to fit. Cut. Paste. And make them nicer. Okay. Okay. And do your plug in. this time, since size is different, continue to plug in. And last this one. Okay. Okay. F prime of alpha. I had this. That could save me a little time. I don't want this video to be too long. It's already too long. Okay. Okay. Actually, get rid of this. Right. Okay. Should be correct. Okay. F double prime. Let's have double prime and calculator. That's your bottom part of your line search. Starting with alpha 0 equals 0, then your alpha 1 should be f prime of alpha 0 over. So what's alpha prime? F prime of alpha 0. That would be this. That's your f prime of alpha 0. So what's that? Use your calculator.
Hey boy, look, I'm gonna make this simple for you. You got two choices. Yes or yes.
Something went wrong because when we plug in, let me double check. Competition. Yeah. Here's different. This guy. Let me just. Our